Okay, so we need to spend a little bit of time going through some notes. And so as we go through these notes, if you ever need to pause the video so that way you can write down what you need to, please, please, please feel free to pause the video, write down what you need to, and then we'll continue on. So you can press play and then keep going. So for this video, we're going to cover the metric system, qualitative, quantitative, um, and then just a little bit about accuracy, precision for just a quick second. So for the metric system, it is by definition the internationally recognized system of measurement. So basically, most of the world uses the metric system, and the United States and a couple other countries, but most of the world uses the metric system. And so there are base units here. So length is typically measured in meters, and we abbreviate meters with a lowercase m. And it's important that you understand that it's always going to be a lowercase m. So that's it's extremely important. Volume, its base unit is liters, but it's abbreviated with a capital L. And again, the capital L is important. Mass is typically measured in grams, and it's abbreviated with a lowercase g. Energy, which we'll talk about later this year too, is measured in joules. So it sounds like the joules that you wear like on your fingers or on your ears, but it's spelled differently, and it's a capital J that we use to abbreviate joules. And then time is measured in seconds, and we abbreviate that with SEC. So for seconds there. So again, if you need to pause to write that down, you are more than welcome. And then unpause when you're ready to move on. So qualitative versus quantitative is another part of the notes that we need to take today and things that you need to make sure that you understand. So qualitative observations are making sure that you can use your senses to observe results. So the examples of your senses are sight, smell, touch, taste, hear. So examples that you could include for that, so if you need to pause the video to write that down and then write down the examples, that's fine. So examples for qualitative could be not that we taste much in chemistry, but you could say that something tastes sour. Or you could hear a popping noise. Or you could see bubbles. Or you could smell something that smells like rotten eggs. Or to the touch, something could be slippery. There are lots of examples that we could use for qualitative observations. So you need to make sure that you have those down and understand the difference between qualitative and quantitative. So again, if you need to pause the video to write down some of those examples, please, please, please take your time, write them down. For quantitative, those are observations that we make with instruments such as rulers, balances, graduated cylinders, beakers, thermometers. These results are measurable. They also usually have a number. So you could say that it was 25 meters long. That's really long, I understand. Or that there were 2 liters of pop. Or that it took you 10 seconds to walk from one side of the room to the other. Or you could say that it was 70 degrees Fahrenheit outside. Again, all numbers and all something that is measurable. Number with it is usually quantitative. I usually think of as quantity. So if someone asks you the quantity of something, you would give them a number. So that's usually how I try to help remember it. So just kind of keep that in mind as we go forward for those things. So again, if you need to take a minute, write down examples, I mean, that it weighed 2 grams, or, I mean, there are tons of things that you could do for quantity or quantitative. There were 3 bears, which, I mean, isn't necessarily made with an instrument, but it is something that you can see that is a quantity. So, yep, make sure we have those things down. And then I'm going to briefly talk over this because you're going to get into it a little bit more in another presentation. But when you make measurements, there's a difference between the accuracy of something and the precision of something. And I think that a lot of students get these mixed up. So when you are accurate, that means that you are able to come really close to the correct answer. But if you have precision, there are two definitions of precision. So number one is being able to get the same answer multiple times. And that's important in science because we want to make sure that if we take the mass of something, that the mass of that isn't changing. Or that, if the same person were to take the mass, they would get the same mass. But the other important definition, and again, both are important, is the place an instrument measures to. For example, if a scale goes 0.00 grams, so that's 2 places past the decimal, that's much more precise than a scale that would go 0.0 grams. So only 1 place past the decimal. So precision is important because if something is more precise, we would have more places past the decimal. So think of it's 2 ways to think about precision, but both are important. And so again, if you need a minute to write those down, please, please, please take your time, write them down, so that way we have those in your notes to be able to use later when you're studying for your test. So this is kind of what we mean, and this is a great way of explaining precision. So if I gave you the latitude and longitude, and what this means. So if I give you 28 degrees north and 80 degrees west, you're probably doing something space related. It's not very exact. Whereas if I say that it's 28.5 degrees north and 80.6 degrees west, that's that extra decimal point there. That one extra place is saying you're pointing out a specific city. So that's maybe saying, hey, you live in Jenison. But if I add one more place, so 28.52 and 80.68, so one extra place of precision is saying you're pointing out a specific neighborhood. So maybe you live in a specific neighborhood in Jenison. Adding one extra place, so now going 3 places past the decimal for both my latitude and longitude, is pointing out a specific suburban cul-de-sac. So you live on this street in this cul-de-sac. When I go 5 places past the I missed the 4. When you go 4 places past the decimal, you're pointing to a particular corner of a house. So not just a house, but the corner of your house. When I go 5 places past the decimal, you're pointing out to a specific person in a room, but since you didn't include datum information, we can't tell you who it is. But it's a specific person. And then, more places past the decimal, you're pointing to Waldo on a page. Okay, think of how small Waldo is when you're looking to find, like, where's Waldo book. It gets kind of small. Or more places past the decimal. Hey, check out this specific sand grain. Think of how small sand is. That many places we could find a specific grain of sand. More places past the decimal, either you're handing out raw floating pointing variables or you built a database to track individual atoms. In either case, please stop. So again, the more places you go past the decimal, the more precise you're able to be. So you don't necessarily need to write this down, but this is a great way of trying to explain how that precision relates to you or how that precision relates to science. So keep that in mind. The other thing that we need to point out real quick, and it probably could have gone back with metric units, I apologize. With this, common units for mass, we measure in grams or kilograms. The kilo is where we get the K that goes in front of the G, but again, G or kg. Volume, when you did your Cornell notes, it talked about that you could do solids as like a length times a width times a height, which is where you would get something cubed. So that's how I would have centimeters cubed. But liquids or gases are typically in, and this should be a capital L, milliliters or liters. And then distance we typically measure in meters. So again, if you need a minute to write this down, please go ahead and pause the video. This is the end of my video, but make sure that you have this down so that way you know how we commonly will measure mass and volume, because we will do that quite a bit this year. So thank you so much for watching our video and have a great day.